Okay.
That's what a spoiled rich kid sounds like.
We don't, oh yeah, exactly.
I'm sorry, not all of us get there, but
All right. But it is nice, though. It is nice on the airplane. Here we go. When you fly international, everyone gets a video. Anyway, here we go. So we're doing inverse of a square matrix today. All right, and so I think then we're going to do determinants, and I think then that's it. Okay, yeah. All right. So anywho. So why do we bother learning about inverse matrices? And specifically, we're gonna learn how to find the multiplicative inverse, right? So for example, what I mean is, okay, when you well, we already know what the additive inverse is, right? So let's back up one step real quick here, or not additive inverse? Yes, additive inverse. Yes. Okay. All right. So. Let's start with this. We'll do it this way. All right. In addition, in the operation of addition, or with the operation of addition, right? Okay. What is the number that you would call, like, what's additive identity? So in other words, what's something that you can add to any number and it'll still be the same number? Zero, right? So we call that the additive identity, right? You can add 0 to any number, and just arithmetic and stuff like that. You can add 0 to any number, and it creates that. And it keeps that number. That keeps it the same, right, kind of thing. So like 2 plus 0 equals 2, right? Okay, so that's your additive identity. Okay, not too crazy there. We'll call that the there we go. 2 plus 0 equals 2. Additive identity is 0. Okay. We also have like the idea of inverses, right? And so the purpose of an inverse, okay, is to take your number and then create the identity. So take your number and change it back to the identity kind of thing. So for example, if I have 3 and I want to create the additive identity, then what do I need to combine with 3? A negative 3, right? Okay, so plus a negative 3, and that gives us then the additive identity. So this, okay, that negative 3, we call that the additive inverse of 3.
Look into that.
Thank you.
Okay. The additive inverse of 3. Why? Because it gives us, when we combine it with 3, we get the additive identity. All right, just like that. This is like a bit of gosh, I feel like this was maybe like I forget, algebraic theory or something like that. I'm not sure what it was, but anyway, this is like some like going way back kind of thing. All right. Similarly, right, we have multiplication, right? So what is the multiplicative identity? 1, right? Yeah, so you can do like 3 times 1, that gives us 3, and so that's the multiplicative identity. And then what is the multiplicative inverse of 3? 1/3, right? So in this case, you have to multiply by 1 over 3. Right? And that gives you then 1. So there's the multiplicative inverse. And then there's the multiplicative identity. Okay, so all that to say then, when we are adding matrices, right? Okay, what is the additive identity for matrices? Like, so if I wanted to take a given matrix and I wanted to add something to it and get that matrix all over again, right? What would I add? Yeah, whatever the dimension is of that original matrix, and then just fill it with zeros, like so that whatever the 0 matrix is there, okay, for additive. But for multiplying, if I wanted to multiply inverses so that I got the identity, right? Remember the identity matrix is 1s in the diagonal, everything, all the other elements are 0s. If I wanted to multiply there, what could we do, right? Would I multiply by 1 over our matrix? And what would 1 over our matrix kind of like look like? Because like, do you just reciprocate everything and stuff? It's like, ooh, I don't know, okay? So how do we find the inverse, right? We want to find a way to kind of be able to cancel out, our original matrix there to get to the identity matrix, okay? And that's the idea of finding the inverse of a matrix, okay? Or multiplicative inverse of a matrix, we'll say, okay? Sometimes, though, okay, in this situation, a matrix will not have an inverse, and we'll call that invertible or non-singular. Okay. So, number one, let's just show that the following matrices are inverses of each other. So if they're going to be inverses, right, and specifically multiplicative, that means we should be able to multiply them together, and what will be our end result?
Same one.
If they're inverses, if it's an identity, so if these things are identities, we should get the same thing. We should end up what's one in matrix? What's the identity for the matrix?
1, 0, 0, 1.
Right, it's the identity matrix is what we should end up with, right? So we're looking to get A times B, and we want it to be, in this specific case, because it's a 2 by 2 times a 2 by 2, we want it to look like this. Oops, almost messed up there. Okay, so this is what we're looking for. Okay, is this true? Okay, and so go ahead, give it a try, all right? Show that they're inverses.
Oh my goodness.
Yeah, we love multiplying matrices here, right?
I hate it.
Yeah, oh, okay, well, I guess I misunderstood.
Always a hate.
Okay, that's good. Extremely dislike. Two minus 2, 0. 2 minus 1.
That's where I was going down.
That is supposed to be just a positive one. Oh, here, I'll just do it that way. There you go. +1, +1.
Hold on.
Okay, so again, first row times first column here, -1, 2 times 1, 1. So it's going to be -1 and the 1. So that gives us -1. 2 and 1 gives us 2. So -1 and 2, +1. Add them up, right? And then for this element, it's going to be first row, second column here. So -1 times -2, +2. -2 times -1 times +2, -2. So +2 and a -2 added together give you 0.
Wait. How did you get the top right number?
This one right here,
Yeah.
it's first row here, because again, just look like it's from the first row of A
Yeah.
and the second column of B.
Okay.
So these two together. So and then
First row times first column, then first row times second column.
that's what I'm doing it this way. Yeah, you can really do it. You can pick whatever element you want. You could start here if you want to, and that's going to be this column and this row that yield
I'd rather not.
that element. Your choice. Yes, where they kind of intersect. Exactly right. Yeah. Mm-hmm. All right. Any other questions on that? So we see. So are these two matrices inverses of each other?
Yes.
Or is B the inverse of A? I should say yes. Okay. Okay. Very good. So let's move on then. Now, our next task here is to find the inverses. Can you just change the numbers around? Yes, we can. Okay. So again?
Are we able to divide matrices?
Are we able to divide matrices? Right. I mean, it's in a sense, yeah. In a sense, maybe, but that's a good question, though. But you don't have the reciprocal, and I don't know how you find the reciprocal. But anywho, maybe. All right. So we want to find the inverse of this matrix. That is, we want to find the other matrix that when you multiply them together, you get the identity matrix, right? Or you want to find the inverse such that A times A inverse gives you the identity matrix there. Okay, A times A inverse gives you the identity matrix. So we know nothing about A inverse, so let's just kind of come up with a generic A inverse that'll have a bunch of variables in it, like so. Okay.
Like the alphabet.
Very good, Michael.
Thank you.
You're welcome.
I'm gonna pick
You're pretty quick on the uptake there, that's right. So, all right, we're going to multiply these two things together. So A times A inverse, and we're going to kind of use this to help us kind of work backwards a little bit, or think about this backwards maybe. I don't know what I want to say, but okay. So I'm going to take my A matrix here. like so. And we'll multiply with A inverse, like so. And we already know what our end result should be. What should our end result be here? What's going to be in this answer here?
1, 0, 0.
Yeah, 1, 0, 0, 1. Okay, right, that's what we want. Okay. So, let's see. Well, we again kind of can work back. So we know then that this row, like for example 1, 4, it's going to have to multiply with the column A and with elements AC to give us a 1. So in other words, we're going to have 1 times A, so we'll have A, and 4 times C, so plus 4C, and that's got to equal 1. Right? So 1A, and then 4C, and that's got to make it the 1 there. Okay?
Really?
So, what? Really? And then we'll do -1 times. We'll do row 2 here, and then again times that AC. So -A minus 3C equals 0. So there's a system right there, right? And then we'll do the same thing with B and D. We'll do the 1 and the 4 with the B and the D. That's going to be 0. So it's going to be 1B plus 4D equals 0. And then it'll be -1, -3, and then the BD there. So it'll be -B minus 3D equals 1. Okay? Now, because again, all I'm doing here is kind of like we're trying to almost like essentially work backwards, right? And just see what we, this is stuff we already know, right? The 1 and the 4 times the AC there is going to give us a 1. The -1, -3 times the AC will give us a 0. So that gives us these two, this system. And then the 1, 4 times BD gives us 0. The -1, -3 times BD gives us 1. And so we get this system. And of course, we know how to solve these little systems right here, right? We can create augmented matrices, right? So, for example, this becomes 1, 4, -1, -3, 1, 0, like that. I didn't use a dotted line. Sorry. Okay. But then this one, what's that? I know. Now I'm completely lost. And then this second system here, it becomes 1, 4, 0, -1, -3, 1. And again, dotted. I'll put the dotted line for that one. Now it's really going to be confusing.
Oh, dotted lines, matrices.
Yeah, there you go. Oh, okay, we're back on track now. Good. Okay. So, what do you notice about these two matrices?
They're like the same.
They're like the same, right? It's the same coefficients, right?
What?
But
There is.
There's a difference.
But there's a difference because, yeah, we got the 1, 0 here, we got the 0, 1 there, okay? And so what we're actually going to do here now, okay, because these coefficients end up being the same, for both scenarios and stuff like that, what we're going to end up doing is actually take our matrix A here, and we're going to augment it.
So, I thought this was just adding and subtracting.
In a sense, it is going to be.
So basically, all you're trying to do is augment
And
that
that does
from the
not
beginning.
sound like anything I've learned.
Yes, exactly. Augment it from the beginning here. You can see because we end up with the same coefficients as we had kind of in the beginning there. But we're going to augment it with, what is this? The identity matrix. The identity matrix, our goal here. Okay?
Is this going to be in our general math when we go to college?
If you take linear algebra, then yes. If you don't take linear algebra, then probably not. Okay? So, we're going to now put this matrix into row-reduced echelon form. All right? So, what will we need to do that? We already have 1 in our upper left. So we'll add them together. So we'll go like this way here, and I'll do row 1 plus row 2 into row 2 there, right? So we'll still have the 1, the 4, but now it's going to be 0 there and 1 there. Oh, that's nice. And because I did that over here, I'm going to have to do the same thing here. So when I add row 1 to row 2, I'm now going to have 1, 0 up here, but I'm going to have 1, 1 down here. So you see my identity matrix is no longer identity. Because I'm going to take that whole row 1 and add it to row 2.
Can't we just do 2 separate matrices?
No.
Yes?
No, okay, then it doesn't.
Yes, if you wanted to. Yeah, you could. Okay, it could. But I mean, this is another way to do it too. All right, what's the last step we got to do here to get row reduced echelon form? RREF.
4 to the bottom plus 2 to the top.
Yeah, so the last step here is we'll do -4 R2 plus R1.
So you get -34.
Okay, so we'll have 1, 0, 0, 1 here.
What is our goal here? I'm sorry.
We are getting the original kind of like A here with so the augmented matrix. We're trying to get this part of the augmented matrix, which is from A. We're trying to get that to the identity matrix.
Okay.
That's our goal.
Okay.
Row reduced echelon form.
But only on one side, right?
Well, right, because you won't be able to do it simultaneously.
Yeah. And then on the other side, we're getting.
And so you'll see here. So let me just show you. So -4 times R2, right? So -4 times 1 is -4, plus 1 will be -3. -4 times 1 is -4, plus 0 is -4, and then 1, 1 right there.
So that would be A, B, C, D.
So right. So this is A inverse.
So we don't have to do what we were doing before, we could just do that.
Oh yeah, exactly, yes. Those all to just show that basically you end up with the same matrix. So it's like, why not just then
I thought this was like building off each other. I was like.
No, in a sense it is. The idea is here that if you try to do this kind of like working the backwards way, you end up with the same exact coefficients as you did before. So we can just use this, augment it with the identity matrix, and then there it is.
But can you do that with all of them?
Mm-hmm. If you're able to find the inverse in the first place, yes, that's how we're going to do it. That is the process. Augment the matrix with the corresponding identity matrix. Row reduce echelon form on the left-hand side. As you row reduce echelon form on the left-hand side, you begin to create the inverse matrix on the right-hand side, because essentially you're like undoing, you're showing what it takes to undo and become the other one.
This is coolio.
Okay, yeah, it's pretty neat.
Wait, I have a question.
Yes.
What's the second one? Well, we're not there yet.
For letter B, okay.
Would it be, is it 1, 0, 1, 0, 1, 0? Does it just like switch all the time?
What do you mean, does it just switch? Oh, are you saying like how do the elements switch around and stuff like that?
Like if you're gonna do like a 4x4 and you have to do the 1s and 0s,
Mm-hmm.
just like you just do like the first row and then you just leave off where you ended off on the left.
So let me just build it here first, and we'll see. Maybe I'll see if I answer your question. So we're going to take B. Let's do this one now. So we'll do 1, 2, 3, 0, 1, 4, 5, 6, 0. Oops, I'm going to augment that with the identity matrix, which is
Cooper Scooper?
like that. Okay. Does this answer your question?
No, like what I thought was you did 1, 0, 1 and then 0. Wait, 1, 0, 1, 0, 1, 0, and then
0, 0, 1. It should be so. This is the identity matrix.
I realize that you have to go straight down.
Yeah.
Yeah.
This is the corresponding identity matrix.
Is that an additional sign?
It's an error. It should just be a dash. Okay, so
Let's try it.
I was gonna say, go ahead, guys, give this a try. So there's your task right there. Row reduce echelon form. I feel like
So when you augment it, when you do a step, you have to do it to both sides, right?
correct. Yeah, you're doing it to the entire matrix when you're doing it. Yes.
So augmented.
Yes, augmenting
What's the deal with
matrices. Sometimes your matrix isn't strong enough, so you need to augment it.
To make a stronger one.
Make a stronger matrix.
What determines a straight down matrix?
Your mom.
I don't know.
We're not there yet.
No, we augment it because this allows us to simultaneously, while we solve this one for the identity matrix, as we create the identity matrix here, this becomes then the inverse matrix of the original B matrix. No doubt, no diggity.
No diggity.
Okay, I think yes.
This doesn't work. Yes, it does.
What step am I at?
Your mom doesn't get it. That's a
Get rid of the 5.
Oh.
Yes.
No diggity.
So -4.
Yes, Blackstreet.
That's not something that
I used to listen to that on the cassette on the way to school sometimes.
Really?
Yeah. Or on a trip one time. It was my friend's cassette. I borrowed it from him and listened to it on my Walkman
You had a Walkman?
Sorry to hear that.
back in the day.
How old are you?
This thing sucks.
It's like the precursor to the iPod.
Wait.
I didn't think you were that old.
You know what the word
I thought you were like.
There were CD players, but the problem with the CD player is that since it's like on an axis and spinning and stuff like that. If you jostle it at all, it can like scratch the CD or it can like skip.
-2.
But cassettes, you can like shake them all you want and they're not going to skip. Plus personal CD players were
Okay. So.
This is literally the ugliest thing I've seen.
Okay, well, I'm going to start getting up here. You can kind of see what I'm seeing.
I just have a
So the first thing I'm going to do is multiply -5 times row 1 to there.
I think I realized what
I can't solve this.
So I add 15. Yes, you can.
can
I
solve
basically
it.
just
I
solved
can't.
it.
Maybe you can.
You can't.
24.
How are you doing this?
Magic.
Every move I do just undoes the last move I did.
Your goal is to get this part
Okay, Sean.
into row reduced echelon form.
Trying.
Kind of ignoring
Normal
this.
echelon form. So you want zeros underneath every that. That's the first thing you want to do. And then once you do that,
10 and 6.
okay.
I can't get it because
You're not right
first
here.
you can't get this one.
Negative
Sean,
15.
Sean, you're right here, right? Which means you have one more step to get this 4 into a 0. Which I did.
That makes that thing a 2.
How did you get it into a 0?
Okay.
What did you use?
And then let's
Why would you
see.
use that one? You would use this one.
Oh yeah, because that one has the 0 here, so it won't affect that.
And also it makes perfectly turns that -15 into a 1.
Okay. I do not like these fractions.
Okay.
Say what?
I do not like these fractions.
So that's 5.
Yeah, fractions kind of suck, but
Yeah, fractions.
Oh, are there bad fractions?
4 times 1,
There are no
Can I use a
fractions.
calculator?
16,
There
1,
definitely are fractions.
4 times
Yeah.
0,
There definitely
4
are
times
fractions.
1, 4 times 0.
That's your mom's a fraction.
Okay, dude.
That's too far.
How do you get a fraction?
Okay?
Do 1/4 row 3. I mean, 1/4 row 3.
Yes. 4, -4 row 3.
4 row 3, not 4.
Bless you.
That means they just still get 5 fourths.
No, because you're multiplying. If you multiply whole numbers by whole numbers, you're not going to get a fraction.
And I'm also going to do.
C says the one.
Whoa, 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 whoa. Let's calm it down here, folks. All right, taking it a little too hard.
It's just math.
You just can't deal with Belgian.
When I was
Goodness gracious.
when I was writing all this out, the top row I wrote as 1, 2, 4 instead of 1, 2, 3.
Okay.
And that has screwed up everything.
Yeah. That'll do that. Yes. That's the fun of these problems, which is why a computer is much better suited to do these things. But we're, of course.
So what I'm hearing is, can we use a computer?
No, it'll be non-computer on the test. But These, believe it or not, like all these like little matrix calculations, from my understanding, one of the major applications of linear algebra and stuff is in computer graphics and such. They use all of the, everything that you see that's generated by computer is made up of tiny two-dimensional polygons that then are fit together to make a three-dimensional image and stuff like that. And all of those like little transformations that you do when you go through a motion or something like that, or that they would do, is done by matrix arithmetic. So your graphics, your $200 graphics card in your computer is just doing a bunch of linear algebra very quickly to move all those polygons around. So application.
I don't feel like doing this again.
I understand.
Okay, I feel like I got the right answer this time.
16,
After getting fractions.
negative 12, and 0.
Because I thought,
Okay, so this is the matrix I received.
You received a matrix.
screw up.
Yeah, okay.
You saw it.
Alright.
Look it up.
20,
So big.
Wait, how did you get it?
negative 4, and 1.
Dude, I'm not good at this. Okay, I suck. So ass at this.
How'd you get 16? I got 25.
How did you get like 20?
Oh wait, you're not done yet. Never
I'm not done yet.
Yeah, see, I have like everything he has once he does the final step. I have no clue what you did, Sean.
How are you guys giving 20?
Because like 5 times 4 gives you 20.
But where do you do that?
You realize
When during this step, when you're doing that, 4 times that.
It's just a lot of arithmetic. When you make one error,
it's 4.
everything gets thrown
Yeah,
out.
4. Negative.
Well, you
You do
can-
negative.
I mean, that would
Okay,
give
so
more
this
for
step.
it.
Did you ever have this step?
I don't know, but I'm like now thinking about grading these, and I'm like,
This one?
So,
I proposed an
Yeah.
idea.
how you propose an idea?
Is equal to 4 multiplied by negative 4. And you also have to do it if you do it to this side as well.
Plus 16. Hang on, 24.
I got the best part of the game.
Yes, things have kind of gone to hell in a handbasket here. So,
What do you take shortcuts? Why are you not writing out the whole matrix? The whole matrix is 6 by 3, bro.
5.
What am I supposed to 3 by 6. It's the whole matrix. You have to write the whole matrix. It's because you're being lazy, Sean.
It's not laziness.
Yes, it is, Sean. You don't write the whole matrix out and then you leave out half the matrix.
Okay, so B inverse
Okay, so I was here.
is
I do not get the right answer.
So it would be 100.
But wait, don't you multiply?
Negative 4.
You could factor a number out of all those. A 1.
okay.
Second. I have a number that's not matching up.
So 1, 0, 3.
I got a
Awesome.
negative. Oh, is that a negative 4?
It's supposed to be negative 4, yeah.
Oh, okay. I thought you wrote negative 8. Okay. Then it's all good.
So that's all correct. 1, 2, 0. Yes.
I like 6.
Good.
I
Yes.
got 20 instead of 0.
You got 20 instead of 10?
Yeah.
Where do you see the 10?
Where do you see the 10?
Oh, that's a 20. Okay, is that a 20? On the 1, 2, 3, the fourth one. Okay, that is a 20.
He has everything down in the bottom of the circle.
What?
And you wonder why I left you for greater cause.
But how'd you get negative 24?
So this one I simultaneously did negative 4 R3 plus R2 and negative 3 R3 plus R1 simultaneously because I knew. So looking here, right, I had a 4 and a 3. So I'm like, I'm going to use this 1 to eliminate both this 4 and this 3 to make them both zeros. I did simultaneously. Okay, because they're going to be separate kind of things. So for this one, I had to multiply negative 4. So negative 4 and negative 5, positive 20. Negative 4 and 4 is negative 16, plus 1 is negative 15. Negative 4 and 1 is negative 4, plus 0 is negative 4. So there's that row.
For my final answer, I got negative 25, 20, and then 5.
What?
And all the other numbers are correct.
I know.
Negative 20 what?
I got negative 25, 20. No,
Sean,
wrote it wrong.
did you fix this step? What you did this step?
Oh, going this way?
Yes, I
What
got
do you
negative
have
25,
on this side of this
25.
step?
Well, I'm then.
But I got all the other numbers correct.
Okay, well, then yeah. I mean, I don't.
What was your right
I can take a look at it if you want me to. Okay.
Is it though?
Where'd you get the 15?
I wrote it down. I don't know, but I got a 15.
Because the mistake you made in the beginning, Sean, is you didn't start running the other side.
So let me talk it through here. For those of you that are having trouble, all right, that aren't quite getting, what we need to get, right? Let me talk it through. So we go so with the first matrix here, okay? And again, you don't have to do it the way I did it, but I think this is maybe the most efficient way, or one of the most efficient ways. So you start with our matrix, augment it with the identity matrix. I saw here that I already had a 1, and so I want to make this 5 a 0. So I multiply row 1 by -5, so that'll give me a negative 5 there, and then adding it to row 3. So -5 times this whole row, adding it to row 3 there. And so then -5 times 1, or let me do it this way. -5 times 1 plus 5 will give me 0. -5 times 2 is -10, plus 6 is -4. -5 times 3 is -15, plus 0 is -15. -5 times 1 is -5, plus 0 will give me -5, and then 0, 0, so it's going to be 0, and then add it to the 1, so it gives 1.
You can work with Sean.
Okay, so far so good? So far so good? Okay, so then the next one here. All right, now I see that I've got a 1 right here, so I'm going to multiply this row 2 by 4 to add it with the row 3. Okay, so 4 times 1 is 4, plus -4 is 0. 4 times 4 is 16, plus -15 is 1. 4 times 0 is 0, plus -5 is -5. 4 times 1 is 4, plus 0 is 4. 4 times 0 is 0, plus 1 is 1. Okay, is this helping anybody right now, or am I just wasting my breath? If it's not helping, that's okay. I just don't want to keep talking. Okay, so no one wants me to continue, right? Okay. Moving on then. Wait a tick. Did he get rid of some problems? He did. All right, well, never mind then. That's it. All right, that's it.
That's what you call a bet.
Okay? I think that's it for today, yeah.
Can I go one of the halls?
No. We have homework. Okay?
Mr. Wade, I have a question.
Yes.
Since we have an odd number of students, is there one group of 3? And if so, could it be me, Mario, and Kurt?
Yes.
No.
Yes.
I don't want a Belgian. I do not want a Belgian.
3, that's racist. 4. So yeah, we still have.
Is that all right?
We're not. It's not gonna be awesome even.
How?
Is she actually a test there?
Okay, I can look back through that. Let me get everyone started on the assignment real quick by passing the papers, and then I'll take a look at it, Madison. All right.
That's what I said.
Papers. Where did I put the papers? Here.
Yeah, I think we got it.
Okay, hello. Sorry. Thank you.
See, look, Kurt, you made me lose my word.
That's not my fault.
Okay, circled problems, folks. Circled
I still have to do
problems.
the other one.
3 problems to make up for the 5.
I know, because I keep on forgetting that we have homework in this class because we haven't had homework for like a whole month.
I guess I should do
This class is doing.
Dude, I'm not even.
Wait, so where
I
was
hope
I?
all the matrices on the quiz are going to be 1x1
Here?
matrices.
I don't know. I think it's still be confusing. I feel.
You know how happy
I
that
was here.
I enjoy how you're eating this piece of bread. It's very interesting.
That's so bad.
No, I'm
That's making me so.
I'm
I'm gonna.
I
Yeah,
don't feel like doing it.
You gonna? Is that driver's license?
Where was I?
Kurt, this is all your fault. I'm a good boy.
She said that she was driving herself.
Yeah, you
Oh, okay. Never mind
I
then.
guess MBA is fine.
Yeah, whatever.
You're
Then.
blaming me like you're doing
All right, let me stop the video and then I'll come back and I'll grab a scone too.
Yeah, there might be a lot of swear words on that video.
Don't worry, YouTube will.
I used
We'll
expletives.
demonetize him. He won't make his money now.
I don't get my money
I'm
now.
gonna get demonetized.
Demonetized.